బయటికి వెళ్ళి కనుక్కోండి.
మళ్ళీ మొత్తం అన్ని కాపీ చేస్తున్నారు
ఇది
అదే
డ్రైవా 5 ఒకటి మిస్ అయింది.
మరేమో ఆ పెన్ డ్రైవ్లో ఉన్నవన్నీ అదే Day 1 Day 2 3 అలా 5 వరకు ఉన్నాయి. అవన్నీ మళ్ళీ ఒకసారి కాపీ చేసి
హలో హలో
Good morning. We reached to the last lecture, and we speak a case study about the application of the membranes. Most of application discussed in the previous lectures, and most we repeat them and remind you. We know that in the recent decades, one of the biggest problems of the humans are problems of the environmental, because the population of the Earth now is more than 8 billion people, and India is the biggest one in the world. And as presented in this drawing, the Earth now is illness, and producing of the many pollutants from human activities, both in gas and both in the water, as well as in soil, cause to the many diseases, unknown diseases in humans. For example, microplastics. Antibiotics, we use the antibiotics for our diseases, but now we know that the antibiotic can be dangerous for human and others. It is a big role, and say that everything that the human is produced is toxic. Everything that human is produced is toxic and dangerous. Therefore, because in production of many of the foods, we use the chemicals, and the using of chemicals is problems. I have some, want to show some problems as a caricature, and you see when we cut the trees, the life of most animals, as well as human. Human is animal also. The restriction of the water and water crisis is very important in many countries, especially in Iran. Iran has very, very crisis state about the water. With the beginning of the cities, we must to remove the jungles, forests, and many other problems. The weather problems, you know, the Delhi is the very bad air in the world, and there are many problems. We can, as an environmental science or as an environmental friendly persons, we must, with use of the science, cause the growing the environmental, and we must treat the pollutants from the air, soil, and weather for greening the life. Therefore, one of the techniques that can be help to this environmental pollution removal can be membrane, because membrane is a separation process, and we can, with use of suitable membrane processes, can remove these pollutants from the environment. About the water, we know that only 1% of the water in the world can be directly drink. 97% of water in Earth is saline, because it's located in ocean and seas, and we cannot use them directly, and we must remove the salinity, remove the pollutants, and after that use. And this cleaning is need many energies, and production of energy is also pollute the weather and the earth. Therefore, the first step for the environmental protection is low using. We must low use the chemicals, the cloths. In the 100 years ago, when we buy a cloth, we put them 10 years. But now we change every day a new cloth, and this is a problem, and other samples we can say. That means the lifestyle of the human is changed, and this is the main problems of the world. As a case study of the most used membrane process in the water and waste treatment water is membrane bioreactor. There are maybe 1,000 MBR plants in the world. Very, very usual and very, very simple method. We have an active slots system as a traditional one, and in this 40 years, for reduction of the biological tank reactor volume, the UF and MF membranes is used for separation of microorganisms. We before discussed that most use hollow fiber membranes, most use immersed one, not external one, and we use the aeration for reducing of the fouling, and the usual MBR unit similar to this one. We first have a particle strainer. That means we use filters. And after that, go to the biological system. Maybe first step can be anaerobic, and second step can be aerobic biological system. And for separation of microorganisms, the MBR is used. And with suction of this treated water, we have a treated water that can be used for agriculture. Most of the treated water from the wastewater usually used in agricultural use, and this can be also a problem because the removal is not complete, and the microorganisms cannot degrade aromatic materials, and this can cause to the going of the pollutant to the body of the fruits, vegetables, and we eat them. Therefore, we reduce the pollution, but when we use in agriculture, maybe have some problems. Therefore, it is better we use, after the MBR, advanced oxidation processes, AOPs, that in these systems, with use of UV H2O2, photocatalyst, phenton, electrophenton, and other radical production process, we can remove completely all our pollutants. In the new systems, after MBR, usually use the AOP processes for complete removal. This is an example of the use of the MBR system in Lancaster City. Another systems that, as I say, use the UV after MBR. UV for complete removal is fabricated in Canada with capacity of 12 mgd million gallons per day. A big one, relatively, and have two steps of the MBR system in calculation of the volume for CSTR, continuous started tank reactors. Usually with dividing of one reactor to two reactors, the efficiency can be improved, as you learn in the reactor lesson. Therefore, in this system, use two parallel, two series reactors for increasing of the efficiency. And after treatment, use the UV for the second step, okay? Because here the concentration is higher. UF in the MBR, the UF and MF is used for separation of microorganisms. In most cases, about the use, we can use UF for water purification, not wastewater. We know water is different from wastewater, okay? Water purification, that means in this factory, in this Kamloops in Canada, use the hollow fiber UF for treating of the UF, drinking water, and the aim is the removal of bacteria, disinfection. And if we have, there are some impurity, such as turbidity, and some of heavy metals. Somehow heavy metals. If there are some heavy metals, tight UFs, tight. We have two types of UF, loose, tight. That molecular weight cutoff can be different. In this case, use the hollow fiber UF for purifying of the water purification. The hollow fiber is used and is the similar, the photograph of these systems. And this is the pumps that used. For this process, two parallel UF is used. Primary UF, about 100 Dalton, 100,000 Dalton, and secondary is 50,000 Dalton molecular weight cutoff. And after the final, use the activated carbon. Why use the activated carbon after UF? Why use activated carbon? What is the role of the activated carbon filter? Which? Exhaustion. Adsorption. Adsorption of the organic pollutant. Some little small organic pollutant cannot be removed by UF. And after UF, use this activated carbon filter for adsorption of the small of the molecules, and also activated carbon can be adsorbed the iron. Can adsorb the low amount of heavy metals. Therefore, it can be used. Another process is nanofiltration. Nanofiltration application is lower than MF, UF, and RO, because nanofiltration process is a new one. Nanofiltration suggested in 1909 years, and it is a new one. but now have a good progress. And the most application of nanofiltration in industry is the removal of hardness, removal of calcium and magnesium from the drinking water in most industrial water treatment plants. Now, for drinking water, we usually use the river and the well water. River water have good quality and the hardness is low. But well waters, due to the contact with the stones, have high hardness. Therefore, in the most water supplying companies, use the well water, and for removing of the hardness, calcium, magnesium, usually use the nanofiltration because the concentration of the NaCl in well water is very low, okay? But we use for seawater directly RO. In this case, because NaCl concentration is low, usually use NF membranes that have higher flux and need lower pressure and lower energy. But the most application is hardness removal that in many Europe countries, this process is routine used. The second is the wastewater treatment. In many countries, use the NF. I checked the internet and see that in India, in textile industries, there are more than 10 nanofiltration units can used mostly for concentration of the dyes. Concentration of the dyes. After dyeing the textile, the concentration of dye reduce because absorb on the cloths, on the fabric. But we have a very, very color solution. Go to the NF, the water is separate, and the dye concentrated, and go back to the textiling or dyeing reactor. Another application of NF is in food and beverage industry. In producing of the cola, Fanta, usually remove the hardness for water and next add the cola materials. In all of the beverage industry, there is a hardness removal plant. In some cases use RO, in some cases use nanofiltration. Our NF can be used in the concentration of milk, whey, or better we say that in fractionation of the milk or fractionation of the protein. In milk, we have different type of the proteins that can be separated with a mix of MF, UF, and NF. NF can be reject the sugar. We can use for separation of sugar from the water and other application, or in some case clarifying fruit juice. Clarify the fruit juice. One application is pharmaceutical industry. We know that the most of the drugs are organic chemicals with molecular weight of about 300, 200 to 1,000 Dalton. The antibiotics and other drugs are mostly aromatic materials, aromatic organic materials with molecular weight of 200 to 1,000. And this molecular weight is good for nanofiltration separation. UF cannot separate, and usually use the nanofiltration for concentration, in some cases concentration, purification of the drugs. And in production line of the drugs, use this nanofiltration for purification and concentration. Most of drugs in the fabrication, in the synthesizers section, we want trans. We know that the trans form of this drug is good as a drug, and cis is not good. And separation of the cis from trans in the drugs cause to the high expense, high cost of the drugs. The synthesizer is simple, but separation need many money, many cost, because the separation of the isomers is very hard, and the need for distillation in vacuum distillation, because for organic compounds, the heat is not good, and we cannot heating in high temperature. Therefore, use the vacuum distillation, or use the nanofiltration or RO for fractionation and separation. Therefore, the most cost of the drugs is related to the separation process. But if we have a good catalyst that can only produce trans one, not cis one, this goes to the reduction of the cost and reduction of the drug money. Therefore, the development of catalysts in the synthesizers of the organic material is very important. And NF can be used in desalination. In some cases that we have a low desalinity, we can use the nanofiltration because need low energy, and mostly used for brackish water. The case study sample in this valley used the NF for natural organic matter removal, and previous the NF used a pretreatment of the microfiltration. The usual use, I say, for the softening, that for removal of hardness, and in most industries use this design for removal of the both desalination and both hardness, with using of the nanofiltration as a pretreatment of RO. Use of NF as a pretreatment of RO, the scaling of the RO membrane is reduced, and the recovery will be improved. In RO membranes, if we use only RO membranes without NF, the recovery will be 60. But with use of NF and separation of the sedimentation agent, calcium, magnesium, we can reach to recovery of 80 or 90%. Therefore, in some cases, NF used as a pretreatment of RO. In some cases, this coupling is mostly used for desalination and water treatment. First, use MF. In some cases, use UF. Use MF and UF as a pretreatment of RO. And after that, advanced oxidation process for removal of the remaining COs. Therefore, now if you check in the internet, you will see that this coupling mostly in recent years used, hollow fiber MF or UF is used as a pretreatment of RO, and after RO, we have a UV H2O2 as disinfection and as removal of the organic matters. Another problems of environmental is the greenhouse effect. You know, when we have a carbon dioxide or water in the air, some of the returned energy can capture it with carbon dioxide and cause to the increasing of the temperature. And this increasing of temperature can be many problems in ecosystem. One of the most application of the gas separation membranes is removal of carbon dioxide from flue gases. That yesterday we discussed about the application of gas separation. And gas separation is very, very important and have a good developing in recent years, and most governments in the world forced to companies that use the gas separation membranes from the flue gases. And now it is a very important research idea, converting of this captured carbon dioxide a useful materials, useful products. This is, can be used as a base of the carbon and oxygen for production of the other products. And now, in some companies, use this for production of methanol. Change carbon dioxide to monoxide and synthesize methanol from monoxide. And methanol then can be changed to the toluene, benzene, xylene. And benzene is, for example, the main matter of the drugs. We can prepare paracetamol, acetaminophen, and other from the benzene. Therefore, we have usually in management of carbon dioxide, separation of the carbon dioxide from the air, storage and capturing of them, and converting of the carbon dioxide to a good product. This slide shows the application of the membranes in dairy industry for fractionation of the milk materials. When we have a raw milk, usually we first separate the fat of the milk. For separation of the fat, we can use microfiltration membrane or centrifugal methods. And after separation, we can manage the scheme of this milk to the different materials with use of the UF, MF, or NF, or RO. Therefore, with the fractionation of the raw milk, we can produce different type of the products. And every of this, for example, way, again can be refractionated to many compounds. There are similar diagrams only for whey. And show that from the whey, for example, we can separate lactic acid. Lactic acid from the whey, and after that produce polylactic acid. Yesterday I said that the main biopolymer now used in the fabrication of membrane is polylactic acid that produced from lactic acid, and lactic acid from the milk and yogurt produced from the whey. Therefore, it is a very green biopolymer. The main application of the RO membranes is desalination, and the biggest membrane plant is related to the RO membranes, and the biggest RO plant is located in Israel. Israel. You know, Israel is a very little country and is very hot and have the very water crisis. And the Red Sea, located in the Israel, have the very high saline concentration, about 70,000. I think the India Ocean is 30,000 ppm, the concentration of the salt. The Red Sea is two times. But Israel produce the sweet water from that Red Sea with desalination and use for agriculture, and is one of the biggest seller of orange and apple in the world. Low water, use the seawater, use desalination, and using agriculture, and is one of the biggest export of the orange to the world, and very delicious orange type, okay? This is show the good management of one country. The biggest one is located in Israel, and the second, third is located in the Persian Gulf. And one of the biggest one is in Iran, as a Fajr petrochemical reverse osmosis unit, is very big. This is one of the pump of these systems for transfer of the water from sea to the entrance of these units. And this is the pressure apply pumps that height is 3 meters. And this one pump you see in the tier, on the very big tier. Therefore, it's very big, and every year, 5,000 8-inch RO membranes is used in this company, and produce the distilled water for petrochemical industries. Iran have a 50 big petrochemical industry and need the water for their process. And this Fajr RO unit produce the required water for these 50 big petrochemical companies. That petrochemicals produce different type of polymers, different type of chlorine, NaOH, acid, and every chemicals produced in Iran. Before this RO, this is the destroyed membranes, that it is environmental problems. These companies say if you can give gift as a gift and come here and go and recover our everything. Every year, 5,000 ones, and the life of these modules is 5 years. That means this unit have 25,000 RO modules for product. Very big one. Before the RO membranes use cartridge filter for removal of particles. And there are many pressure vessels for cartridge filters. And use acid and anti-escalants in the feed of the RO for controlling the scaling. With use of anti-escalants, we reduce the possibility of the sedimentation. Another application of membrane in petrochemical in Iran is the use of the tubular polymeric membranes. In the production of the PVC polymer, one method is suspension method. We have an emulsion method and others. One of suspension method, that means the polymer particle produced in water as a solvent. In emulsion, we have another solvent for production of this. For concentration of the water and separation of the produced powder from the reactor, two devices used. One is UF, tubular membranes, that they reduce 40% of water, and the remaining concentrated water go to the spray drying. This spray drying is very big, have a 30-meter height, and the heated concentrated of UF is sprayed from the top, and to reach to the bottom of here, all of water vapor, and powder reach to the bottom of this spray dryer. Therefore, UF can be, tubular UF can be used for separated of the particles from suspensions. Another application of the proton exchange membranes, naphthion and phlegmion, is in the production of chlor-alkali unit. This is the photograph of the Arvand petrochemical in Iran that use the NaCl as a feed and use the electrolyzers for electrolyze NaCl to NaOH, chlorine gas, and hydrogen gas. Okay? You know this reaction. With electrolyze of NaCl, we have a chlorine gas, H2 gas, and NaOH. The main of the purpose of this petrochemical is producing of chloride. The petrochemical need this chloride for reaction with ethylene, okay, to produce ethylene chloride. Ethylene chloride, okay, hydrogen. And this ethylene chloride produce PVC. As shown in this slide, you see Arvand, similar petrochemical. The main product of this petrochemical is PVC polymer. For production of the PVC, need chloride. This color reacts with ethylene, produce ethylene chloride, and this polymerized to PVC. But have the byproduct, hydrogen is used for heating, go to the heating system and combust with oxygen. And NaOH is, can be changed to the dry NaOH, or can be mixed NaOH with chlorine for production of the whitening solution. Whitening solution, what you say in India for whitening of clothes?
Washing soda.
Washing?
Soda.
Soda, washing soda, yes. With combination of this with chlorine gas, we have a wax solution. Therefore, have many products, but the main product PVC. And for production, electrolysis need to the exchange membrane, Nafion exchange membrane. And you see have a very big stacks. And for here see, this is one electrode, and this is another electrode. Between two distance that is very, very low, you compare with the tube diameter, we have a one cation, and anion exchange membranes. Another most application of the RO and NF is in the cooling towers. Do you know what is cooling tower? These towers, maybe you see. What is the role of this cooling tower? In the production of the electricity, we have hot reactors and should be cooled with water. For cooling of the electrical production reactors, use the cool water, and cool water come contact with the reactor, and the warm and the hot water should be cooled for regain use. Okay, here is usually 30. Here is usually 80 centigrades. For reducing of this water that have a very big volume, use these cooling towers. In cooling towers is the simple mechanism. The water can pour from 50 meters, spray to the ground. And during this pass, some of the water can be evaporate, and when evaporate, give the energy of the water, and this evaporation cause to the reduction of the temperature. Therefore, this most very simple one, but in this type, we have some trays, some cascades for increasing of the water pass. And the height of this is lower. This is the 50 meters. This is usually 20 meters. But the simple, with evaporation, the temperature of water is reduced. But when we have evaporate, we know that the water evaporates as a pure one. No salts evaporate. Therefore, after a certain time, the remaining water will be very solid, because water evaporates and solid remain in water, and the conductivity of the solid can be increased and cause to the sedimentation and other problems. Therefore, we must reduce the desalinity, and in this case, usually use the small RO or NF plants. Small with you see for in this case have 18 pressure vessels. If its pressure vessels have 5 modules, we have 90 RO modules. This is a simple, small plants, but in every production, electricity production, we have this RO units for desalination of this water. This is another RO unit that supply the cooling water of Tabriz petrochemicals. I have some project with these petrochemicals, and I share my experience. And another big consumption of the water is the production of steel iron factories, and need a lot of the waters for production, separation, and molding of the irons and steels. Therefore, need the water and pure water, because the presence of the calcium, magnesium can be a problem. And in Iran, there are also big RO units for producing of the steel factory water. Thank you. I share some this application. There are also many applications for other processes that I not discuss. Dr. Raka discussed about the application of the membrane in fuel cells, different type of fuel cells, and the storage of the hydrogen and other application. For example, per evaporation, I show Sulzer company for separation of the ethanol, separation of water from ethanol and reaching to absolute ethanol. That's used in Brazil most, and many our now membrane distillation is used in Persian Gulf for increase of the desalination recovery, because the most RO units in the world are located in the Persian Gulf, in Kuwait, Emirates, Qatar, Iran, because have the water crisis. India have a good humidity, but in Iran, Qatar, we have no humidity, and we all of the desert, no forest, no jungle. Therefore, the water is very important in Middle East area. Thank you. If any question?
Any question?
Production, which materials? We discussed before, for production of RO membranes, we use the polyester fabric as a supporting layer. We coat polysulfone on the non-fabric. That polysulfone in industrial scale dissolve in DMF. And after that, we coat TFC layer that we have a two-step, MPD in water and TMC in hexane, okay? But we have some additives in TMC and MPD solution. In MPD solution, we add 3-ethylamine as a base, camphor sulfonic acid as a catalyst, and SDS, sodium dodecyl sulfate, as an increasing of the penetration of MPD to the membrane structure. And after production of the RO TFC, we coat with polyvinyl alcohol. And before polyvinyl alcohol, for removal of the excess MPD, we use acid citric solution and keep the membranes in sodium bisulfite disinfection. And many components can be used.
Sir, with respect to softening of the water, this MF plus RO, then UV is a best combination, you said. Similarly, for drinking water production and also for wastewater treatment, what is the best combination of these filtration membranes?
RO membranes completely remove everything and only pass the water and very little amount of the salts, okay? But for reducing of the fouling of the RO, we can use MF, UF, and NF before RO. MF is used for the particle separation. Maybe cartridge filter cannot be true, and we use MF for insurance of the no particle come to the RO. UF, if we use UF can remove some macromolecules, especially natural organic matters that there is in the seawater, and humic acid. This is the two problems in membrane fouling, because in the seawater we have a fish and another animals that produce some organic matters. Therefore, this, when go to the RO surface, can increase the organic fouling. Therefore, we can use the UF for separation of humic acid and natural organic matters. If we have a high hardness, we can use the NF before RO for removal of calcium, magnesium, sulfate, because these components can cause grossing of the calcium sulfate, calcium carbonate on the membrane surface that I will discuss after high T about the fouling. And after RO, we usually have no membrane. We have exceptional and use of MD, membrane distillation in the concentrate for more desalination. After RO, we usually have a disinfection with UV or chlorine gas. If we have a very low COD, that usually is very low, 2, 3, 5 ppm, we can use UV H2O for complete removal.
Okay, sir.
Sir, you mentioned earlier about anti-scaling agents that is being used in case of the
anti-escalant. Okay.
Yes. So what sort of
what is anti-escalant? Huh?
No. What kind of materials or what kind of things that you used as anti-scalings? Because scaling, if you consider, whenever it's in salinated water, that is going to be there.
Yes.
Isn't it? But
which type of materials used as an anti-escalant agent?
Yes.
Okay?
Yes.
I will discuss in the tutorial.
Fouling.
I discuss.
Okay.
Yeah, okay. Different type of anti-escalant campaign, and the mechanism is interface with calcium. We have a ligand, soluble ligand. When complex with calcium, produce soluble calcium compound, and do not permit to reaction with sulfate for precipitation, carbonate for precipitation. Therefore, we have an interface between the calcium sulfate, calcium carbonate. Or another mechanism is that anti-escalant do not allow to attachment of the crystals together. We produce calcium sulfate that won't precipitate, but anti-escalant connect to these sediments and do not to agglomerate and produce big one, and are suspended in the feet. I will discuss in details.
I believe those all must be the MS pipes.
MS?
Pipes. I mean to say the pipes, those are being actually used. Sorry.
Echo, yes.
MS pipes are there, right, I believe?
MS?
Steel pipes.
Magnetic?
Material construction you mentioned, sir. Mild steel pipes.
I do not understand.
Steel. This is iron
Steel,
pipes.
yes.
Iron pipes.
Iron pipes, what is problems?
No, corrosion usually actually takes place in that.
Yes.
So I mean to say that we cannot use the steel pipes in that cases.
Yes.
But however, the MS pipes that we are actually using, that might be the cause, the corrosion then.
Yes, the corrosion is important in the membrane process. Before in the entrance of the RO membranes, because we have a high pressure, we use stainless steel. And after the RO, both in concentrate and permeate size, we use the HDPE, high density polyethylene tubes, and this reduces the corrosion. But in the feed side, we add, reduce the pH, because the reducing of the pH causes to the low sedimentation, and therefore we will have corrosion. But in industry, we have a different type of steels. Have a coat, say 360. That is the good resistance for corrosion. And we have a very acidic solution. We have a titanium-based corrosion tubes, resistant corrosion tubes. Therefore, we have a corrosion, and we can manage them. And this corrosion can go to the membrane surface and cause damage. Therefore, we have a 2 or 3 cartridge filter after the sand filter and carbon filter. In the RO units, we have a first sand filter, carbon filter for removing of the COD, very low amount of COD. After that, we use 2 or 3 cartridge, 10 micron, 5 micron, 1 micron. And 1 micron direct connected to the RO entrance, and 1 micron located between the pump and RO. Between the RO entrance and pump, we have 10 meter distance. But we have located one micron filter because maybe we have some corrosion in the pump under some tubes, and one ion particle is very dangerous for RO membrane. Therefore, we protect the membranes from the corrosion particles.
Sir, can you capture carbon dioxide from flue gases in the membrane?
Yes.
But isn't that cause high fouling? Because flue gases have too much dust and other particles.
Fouling in the gas separation, I say we have not fouling. We have a plasticization and aging, okay? And also the particles is dangerous for gas separation. And before the entrance of gas separation, we also have cartridge filters for removal of the particles. Yes, after 3-4 years, the gas separation can be plasticized, can be brittle, and should be replaced because especially carbon dioxide. Carbon dioxide reacts with the polymer change and change the chemistry and change the free volume of the membranes.
So what kind of membranes do you use for carbon dioxide capture?
Mostly polyimide and polyimine vinyl. We know in absorption column that amine groups can good absorb the carbon dioxide. Therefore, a polymer with nitrogen groups have better carbon dioxide absorption. Therefore, polyimide, polyimide, polyimine have a good absorption of carbon dioxide, and most of the carbon dioxide gas separation membranes fabricated from these polymers.
Also, sir, suppose I want to do carbon sequestration, so I need to convert gaseous carbon dioxide into liquid.
Okay.
So the membranes absorb carbon dioxide, right?
Yes.
So how to convert into liquid? Is any specific desorption process?
Can change the carbon dioxide to liquid. Gas separation separates carbon dioxide from a flue gas and go to the storage tank. With compressing, we can change the carbon dioxide to liquid and solid one. We have a carbon dioxide solids that in the air produce the vapor. This is used with the compressor, not with membrane. Only membrane separate, and the permeate go to the tank and compress with compressor.
Sir, is the UV beneficial for like in wastewater treatment? The use of UV
Beneficial of
for wastewater treatment.
wastewater
Treatment.
P?
Treatment.
Treatment, yes.
The
Beneficial of membranes.
Yeah. No, I mean the use of UV.
UV, why we use in the
Yeah.
UV have two effects. One, disinfection. With irradiation of UV to bacteria, the microorganism and bacteria will be deactive. You say deactive, it's the diet. UV causes to the dying of the bacteria. And the second one, UV can degrade. UV is a high energy and can degrade the organic matters to the little one. And if we have enough time, all of the carbon compound can be converted to carbon dioxide. That this is named degradation. Okay? Disinfection and degradation.
So it's like you can we can use it only like you just UV for wastewater treatment, or should we add another process?
No, UV, yes, UV can be used alone.
Alone, yeah.
We have quartz tubes, and water comes from quartz tubes, and we have located UV lamps around these quartz tubes, because UV cannot pass from glass. We must use quartz. And when water go from 2 or 3 meters of UV lamps, during 2 seconds, 3 seconds, the bacteria can be deactive. Directly only use UV. Only use of the UV for degradation is not effective, not efficiency, because in this case we use another aiding compounds, such as hydrogen peroxide, such as sulfonoxide, sulfates, peroxides. Some chemicals we can add that help the UV for degradation. Or we can use photocatalyst that can be active with UV. When our water have photocatalyst and go inside of the quartz, the photocatalyst react with UV and produce radicals and cause to the degradation.
Thank you.
Any other question? Okay. Let me please join me in thanking Professor for his wonderful lectures. And thank you very much. It was the last lecture of this course. So next we have tutorial, but before that, please join me for tea in 312. Okay.
Most of the times, actually, I always wonder why these students are not using the plastic pipes to for channel, because it all
As the last meeting, we reached to the membrane fouling. We speak mostly about the advantages of the membranes and applications, and we say that the membrane is very good because we work on the membrane science. But membranes have some demerits, and the main demerits is membrane fouling. The process of membrane is easy, and the fabrication and the fabrication of a plant is very simple. We need some cartridge filter, some tubes, some pressure vessels, and some pumps. But the maintain of the membranes is very important, and need to good science about the membrane science. Some plants change every 2 years the membranes, and similar plants in another city change 5 years the membranes, because the engineer of the 5 years have a good science about the membrane keeping and cost control of the conditions for reducing of the membrane fouling. Therefore, we must learn about the mechanism of the membrane fouling and try to reduce the fouling agent, named as foulants. Fouling agent that cause to the fouling. Generally, we have 4 types of fouling, 4 types. One is colloidal fouling. That means the fouling agent is colloids and particles. Particle fouling or colloidal fouling. Why say colloidal? Because we can separate particles, big particles, and colloids is very small and charged particles. And in some cases, the cartridge filters cannot good remove the small particles that we say colloids, and therefore we can have a colloidal fouling. Colloidal fouling is important in microfiltration membrane, because in the microfiltration membrane we mostly separate the particles, separate the bacteria and yeast or the turbidity. Therefore, in this case, the colloidal fouling is important in microfiltration and ultrafiltration membranes. No important in reverse osmosis, because we don't allow to reach the colloidal to the RO surface. If reach, RO rapidly will be removed. The second type of the fouling is biofouling. Biofouling, that means the reason for fouling is the bacteria, viruses, and living microorganisms. The third one is organic fouling, that the foulants are organic matters, such as dyes in textile wastewater, natural organic matter, humic acid in seawater and rivers, and proteins in milk filtration, and another. The famous one of the fouling is organic fouling, because we have many types of process that we want to concentrate these organic matters. We have concentrate the milk, whey, proteins, fruit pulps, and others, and all of have an organic nature. And the fourth foliage is sedimentation foliage, sediment foliage, precipitate foliage, that's named as a scaling. This type of the foliage is named as a scaling and important in RO, NF, MD, important in desalination process. In this case, we have a sedimentation of saturated components with increasing of the concentration of the salts in the surface on the surface of the membrane, with reaching to the saturation point, the extra salts that cannot be dissolved in the saturated solutions will be precipitate and cause to a new layer on the membrane surface. And these crystals can act as a knife and can destroy the membrane surface, can cut the membrane surface. Therefore, this type of foliage is very dangerous. The colloidal foliage can be removed easily, but the scaling is hard. Excuse me. This is also show another schematic about biofoliage, inorganic, organic, and colloidal. For porous membranes, we have different types of the foliage based on the chemistry and size of the foulant and pore size of the membranes. We have a standard blocking. That means the pores is open in standard, but the molecules, the foulants, attached, absorbed on the surface of the pores and reduce the diameter. But in standard foliage, the pore size reduce and the flux reduce because some of the pollutants can absorb on the pore side. One is the complete blocking. In this case, the pores completely block with the foulants, and we have a cake layer fouling or gel layer fouling that we have an extra layer in the membrane surface. This is an example of the colloidal fouling. These photographs, SCM image, have given from the membrane surface with fouled membrane. And we see that the particles cause to the increasing of the membrane thickness, and we have a new layer, that this new layer can cause to reducing of the membrane flux. This is an image about the organic foliage, and you can see the gel layer on the membrane. Membrane is white, but produce a gel layer. This membrane is used for natural organic matter filtering, and after fouling, give the analysis for characterization of this layer, and shows that the most of them is alginate from algae. From the seawater, there are algae, produce alginate, and alginate fouling very bad in the case of the calcium. When we have a calcium in the water and alginate, calcium can act as a bridge between the alginate and cause a adhesive, and very, very bad fouling can occur when we have a calcium with humic acid or natural organic matters, and produced a layer as a cement on the membrane surface. Therefore, in the entrance of RO membranes, we must use the TOC lower than this amount, 4 ppm. If we have a higher TOC than 4 ppm, we will have a very bad cleaning in RO and NF surface. This shows the scaling or inorganic fouling. We say what is the mechanism of the scaling. When we have a fresh feed on the membrane surface with passing of the permeate, the concentration of the salts on the membrane increase, and when close to the saturation point, some nucleus are produced and cause to the more growth of the nucleus, and we have a crystal layer on the membrane surface that's based on the crystal type. The crystal type of calcium sulfate is different from calcium carbonate. And therefore, we can have a different structure on the membrane. You see here, you see the producing of the salts in the entrance of the spiral wound modules, or here. And this growth of these salts, these crystals, completely block the entrance of the modules, and the feed cannot go. And in this case, we have a very high pressure drop. We increase pressure from 20 to 50 atmosphere, and in this case, we need high energy for this matter. Scaling mostly can result from calcium and magnesium, but presence of low amount of heavy metals, especially zinc, especially nickel, manganese, iron, or aluminum. We have a coagulation process in the water treatment. That in coagulation process, we add Fe chloride or alum sulfate as a coagulation agent. And in some case, the possibility of the iron and alumina in the feed is high. And this can cause to the rapid sedimentation of the inorganic layer because the solubility of these salts is lower than. The complex of the calcium and magnesium, for example, with hydroxyl, with sulfate, is low, but the tendency of heavy metals for precipitation is high. We usually have this KSP. We know each component that can be precipitate have a KSP. The lower KSP, the minus KSP, means the rapid sedimentation behavior. We say that the calcium carbonate, in comparison to aluminium, have more solubility. Aluminium hydroxide is very, very low soluble. Therefore, when we have a very low amount of aluminium, our phosphate, our both phosphate, our zinc hydroxide, or when go here, iron, Vu very minus. These components can increase the scaling possibility. Therefore, if we have a low amounts of zinc, low amounts of aluminium, low amounts of lead, it may be, we must first remove from the feed of RO. Therefore, I say one plant work 2 years, another plants work 5 years, because the 5 years one is used good pre-treatment. And when we have a good pre-treatment, we have a use good anti-escalant, good pH adjustment, we can reduce the possibility of the scaling with controlling of this KSP. All of this KSP related to the pH. All of this KSP is related with change of the pH and temperature also. This KSP can be changed because the acid can be interact with hydroxyl and can cause to the change of KSP. We know that with, for example, calcium wants to complex with phosphate, okay? With increasing of pH, we change phosphate to acidic one. With reducing of pH, this change, for example, to this one. And this one have a low tendency to complex with calcium. And therefore, the KSP is changed. Therefore, with addition of the acid, we can change the hydroxyl carbonate change to bicarbonate. And other sulfate can be changed to the bisulfate and others. Therefore, we have a controlling of the pH for reducing of the inorganic sedimentation. You see a SEM image from this model. This model is destroyed, open, and give a SEM image. Here is membrane. You see, if the thickness of the membrane is 50, we have almost 2 times constant height of the inorganic materials, and you see with different structure. I think that have an earthquake and a building put on the membrane surface, okay? Therefore, this goes to the destroying, and you see these crystals can act as a knife and cut the polymer. Therefore, we must control the conditions of the membrane for reducing of the fouling, and we need to washing and cleaning of the membranes. In dairy industry, we every day wash the membranes with hot water, and every week we with cleaning agents, such as surfactants, such as acid base in dairy. In RO, we usually wash every month the membranes. When I say wash, that we use only water, or water with air bubbles, no chemicals. When we use cleaning, that means we use cleaning agent, but when we say washing, we use only water with mechanical cleaning, such as bubbles, okay? And usually, every 6 months, clean the RO membranes, NF membranes with cleaning agent that based on the foulant type, use different cleaning agent. For these crystals, that is inorganic compounds, mostly use acid. Acid can dissolve these minerals and remove them. But we know the acidic solution is toxic for polymeric membranes. Therefore, after 5-6 times of cleaning with acid, the membranes will be destroyed. Every 6 months, when we clean 6 times, after 3 years, the membrane should be changed. Therefore, cleaning is also destroy the membranes. We can use EDTA. EDTA is a complex we use in titration for measuring calcium, magnesium, and others. Okay? We use in the shampoo for complex with the calcium and reduce the hardness and cause so that the shampoo, soap have a good foam. EDTA can complex with metals and produce the soluble complex. Therefore, with using of EDTA in cleaning agent, we can rapidly dissolve these ones. And other cleaning that I will discuss in the last slides. In the RO, we have a Langelier index that equal to the actual pH minus saturation pH. Which pH goes to the saturation and actual pH of water, what is that? And for calculation of the saturated pH, we have this equation that shows the most components that cause this layer in water, in river water, in well water, is the calcium and bicarbonate. Therefore, we can use of this equation, we can calculate the saturation pH with having of the calcium concentration and bicarbonate concentration that we easily obtain with titration with EDTA and titration with acid. Okay? If the Langelier index is bigger than 0, tend to participate. If the lower than 0, tend to dissolve. Okay? Bigger than 0. We calculate the saturation pH is 6. Our river pH, water pH is 6.5. Therefore, it's bigger than 0, and this goes to the precipitation. Therefore, we add acid to the feed and increase pH to lower than 6. We go to the 5.5. Okay? Why we do not use, for example, 4 pH 4? We know when we we reduce the pH and reach to the force 3, the possibility of this formation will be reduced. But we do not reduce the pH because causing the corrosion, pH, reducing the pH, the corrosion will be increased in the pump. And also the acid can be destroy the membranes, polymers. Therefore, only we very low amount reduce to decrease the sedimentation possibility. I discussed. Scaling layer can be different from one water to another water because the chemistry of water can be different, and also maybe another organic fouling, microorganism fouling, biofouling together. Therefore, for comparing with that one membrane surface, for UCLA wastewater is different from Montana State University. This is I think this is have a organic falling together with inorganic, but here we have only inorganic falling. We see good crystals, but in this case we see some polymeric change, maybe from alginate, lignin, and other natural organic matter. Therefore, because based on the chemistry and water source, our routes, our control can be changed. Therefore, from one plant to another plant, the management of the system can be different, and the engineer can be find the reason problems for falling and try to resolve them. For reducing of the scaling, after pH adjustment, we can use some matters, some materials that reduce the scaling possibility. The famous one is a phosphonate families. They are different type of this compound that we use. This is a phosphonate families. Or can be used dendrimers, can use polyanions as a polyelectrolyte and others. For example, in the similar wastewater, use similar membrane, one no inhibitor, no anti-escalant, and another only used 5 ppm of phosphate inhibitor in the feed. The scaling agent is used in very low concentration, 1 ppm, 2 ppm, 5 ppm, 10 ppm, not more than 10, okay? With addition of very low amount of this anti-escalant and testing for 1 week, 1 month, they are give this SCM image on the membrane surface and see that the anti-escalant reduced the formation of the crystals. Usually we have 2 mechanisms. We have many mechanisms. Change with the type of the anti-escalant. But we have 2 main mechanisms. One mechanism is the change of KSP. We see that previous slide in this. We have a KSP for any of this sedimentation. When we add a second ligand, we have a metal and sulfate is ligand, okay? Our complexing agent. When we have a new ligand, such as phosphonate, calcium wants to react with phosphonate instead of the sulfate. Therefore, there is an interface. There is a combat between calciums for reaction with phosphonate, not want to reaction with carbonate or sulfate. And phosphonate calcium complex is soluble, not insoluble. If calcium react with carbonate, will be precipitate. If react with the phosphonate, don't precipitate. Therefore, one mechanism is the change of KSP and cause to the soluble complex. The second mechanism is that, such as these polyanions, polymers, dendrimers, can connect to these crystals where are alone. You see that after producing of these crystals, all connected together and produce a bigger particles or produce a layer on the membrane surface. In this case, most in polymers, the polymer connect to the produced crystals and do not allow to more growth. After nucleation, the crystal began to grow during the time. But these polymers connect to the small particles and do not allow to growth. And when do not growth, the cross flow velocity of the fluid after a certain time can this pull and exit from the RO modules. Therefore, the attachment of the crystal can be reduced with some polymeric anti-scalar, and there are many mechanisms for that. The temperature of the feed can be influenced. There are many parameters can influence. In this study, shows that when the feed concentration is 5 centigrade, we have a less gypsomic scaling, and when the temperature increased, we have a enhanced gypsomic scaling. That show, in this case, the reducing of temperature can be good. Therefore, the growth of the crystals, the reaction between calcium carbonate, calcium sulfate, is a chemical reaction and have thermodynamic and kinetic parameters. Therefore, with change of temperature, the growth rate can be changed. In this case, we see that the increasing of temperature is bad for membrane from fouling view. But we know with increasing of temperature, the flux can be increased. Okay? We have a two trade-off. Increased temperature is good for flux, but bad for gypsum scaling. The biofouling is the bad fouling because we know the bacteria and the microorganisms had very rapid growth. During 1 day can be 3 times increase the concentration. Therefore, if we have a microbe or microorganism on the membrane surface, it can be rapidly grow and prepare some big colonies. This is show that when the microorganism can reach to the RO membrane surface due to the bad performance of sand filter, cartridge filter, during maybe 1 month, the membranes completely destroy, and you see the color of the membrane change from white to dark brown. Therefore, the biofouling is very bad fouling and can rapid growth. We say in previous lectures that for increasing of recovery, we usually have a 5 or 6 or 4 modules inside of the pressure vessels. We have a long pressure vessels. We put 5 modules. Each module have 1 meter, and therefore this pressure vessel have usually 6 meters, because between each modules we have a free space of about 10 centimeters. In this slide, we say that the fouling is related to location of the modules also. When we have the feed entrance here, from left feed entrance, and from the right, the concentrate exists, okay? And we have 6 modules. In the first module, we have a organic fouling mostly. If the feed have an organic matter, the most foulants, organic foulants, can be attached to the membrane surface in the first module. And when the module can absorb the foulant, organic foulant, the concentration is reduced. And in the last module, we have a very low organic foulants because adsorbed, and therefore this module have a very low organic foulant because mostly adsorbed in the first one. Reverse, in this case, we have a desalination process. In this case, I write here, for example, our feed have a (3,000 ppm desalination. Every module have a 15% recovery. That means from this ppm, and for example, we have a 100-liter solution. In this case, if its membrane act as a 15% recovery, 15% in 6 modules, we will have 90% recovery. That means here we have 10-liter concentrate, and as a permeate out, we will have 90 liters, okay? When we have a 90% recovery, that means 90% of feed will recover. That means here, if we have a 100 liters of feed, 90 liters will be permeate, and 10 liters will be concentrate. The concentration of the salt in the feed is 3,000 ppm. And we assume that we have a 100% complete rejection. Usually 99, we assume complete. That means all of the salts will go to the 10 liters. Therefore, in this case, we will have ppm salt, okay? The permeate is pure distilled water, no salt. All of salts from 100 liters go to the concentrated solution. Therefore, concentration will be increased from 3,000 to 30,000. Therefore, here we have a very possibility to saturation. 10 times we have a thicker solution. Therefore, in the last modules, we will have a possibility of scaling because with going to the right, the concentration of the salt increases, and in the last one, we will have a very bad scaling concentration. Therefore, the fouling is related to the location, and in industry, in annual repairment, usually change the location of these modules. Give this one, for example, use as a 2-1. Change the location of the membranes for long life. The main reason for fouling began start from the concentration polarization. As we know, the concentration of the solutes, the molecules, from the bulk to the concentration polarization layer is different. As yesterday, Dr. Raka have some solution problems for you. In the first problem, say that the concentration of the molecules 25 times higher than the bulk in the first, okay? The concentration in the surface 25 more than the bulk, and this means in the previous slide, we say that the concentration of the feed is 3,000 ppm. This concentration is in the bulk. We measure the bulk, not can measure the surface. Therefore, we have actually the concentration of the salt in the membrane surface may be 6,000, 7,000. Okay? Therefore, this concentration polarization, because increase the concentration of pollutants on the surface, cause the fouling. Therefore, the styling is very important in the membrane surface. And we try to have a turbulence fluid regime on the membrane surface. We must have a Reynolds bigger than how amount for turbulence? This number. We must, the Reynolds number more than usually 3,000 on the membrane surface, and the feed speed is very important. Feed speed is very important in the spiral wound, and when we want to buy a module, one of the parameters in the brochure of the membranes is the feed speed entrance. Every higher feed speed, we have a big Reynolds number. We have the Reynolds number, rho, v, d, and mu. And this is the velocity speed. Higher velocity is good for reducing of the concentration, polarization. But higher velocity, that means higher energy, higher pressure. And this causes the deformation of the module. When we have a rapid growth, we have maybe our configuration destroyed. Therefore, in the brochure, in the catalog, say maximum feed speed. And this module should be test maximum feed speed. We want to increase the speed, but maybe the module can be degraded. I go this one. There are different resistance in the membranes that we can calculate them with filtration of the proteins that I discussed yesterday. We test of pure water, foulant, and second water. We have a different type of the resistance. First one is the membrane intrinsic resistance. When we have a pure water flux, we know that the big pores in the membranes is meaning the low resistance. When we reduce the pore size, the flux reduces. That means the resistance increases, okay? Therefore, we have an intrinsic resistance that's related to the membrane chemistry and membrane pore size. We have an adsorption resistance, that's standard resistance, that this resistance can be reduced the pore size. We have a gel resistance or cake resistance. We have a concentration polarization resistance, that's difference in concentration. We have a pore blocking resistance, that means completely or mostly blocked with the pores. Based on the flux, we can calculate them that have equations, and this is the routine method. Yesterday I discussed that we can obtain flux recovery ratio with measuring second flux to first flux, reversible fouling and irreversible fouling, that based on the BSA flux, we can obtain these ones. In this slide, I try to define the fouling. For reducing of the fouling, we have three general techniques. One is pre-treatment of feed. We can identify, characterize the fouling agent, fouling reason, and remove it or reduce it. Okay? This is the best method that we can control the fouling agent. For example, using sand filters, carbon filters, different color filter for removal of a particle and colloids. Using carbon filters for absorb heavy metals and organic substance. Low concentration chlorination to prevent microorganism growth. We have a 1 ppm chlorine dosing in the feed water of RO. This chlorine as a disinfectant do not permit the growth of microorganisms, but I said before that this chlorine can cause to the degradation of membrane in RO, and one of the research is the increasing chlorine resistance of RO membranes. Okay? Polyimide can be destroyed with chlorine. pH adjustment to reduce the possibility, and use of anti-escalant. Therefore, the better one is the pretreatment. We control the conditions of sedimentation. The second one is the membrane modification. We can increase the membrane resistance to fouling. For example, when we have antibacterial membranes, the microorganism cannot be gross, because when come to the membrane surface, will be deactive. Or we can control the pore size. Pore size is very important. When we have a uniform isopore size or narrow pore size, the fouling is very lower than when we have a wide pore size. That means one big, one small. Or we can change the polymer, membrane chemistry. With change of the membrane chemistry, we can reduce the attachment of the organic foulant. With increasing of hydrophilicity, the most of organic matter attachment reduce. Because we increase hydrophilicity, and hydrophobic materials cannot attachment, and there are many. And the bad method that we do not act this way, this is washing and cleaning. When our membrane is full, with washing and cleaning, we can recover them. So this is the Gauss parameter, and I discussed them and some examples in the another slides. For pretreatment of the feed solution, heat treatment, for example. With increasing of a heat of feed in dairy industry, we can reduce the membrane fouling. Fat of milk in the cold temperature rapidly causing of the fouling. But with increasing of temperature, the oil and fat fouling can be reduced. pH adjustment, anti-escalant, chlorination, and others. Membrane properties, I say that we can increase the hydrophilicity of membrane or control the pore size. Module and process condition, I discussed with a turbulence promoter, we can increase the mixing on the surface and reduce the concentration polarization. For turbulency, we usually two methods. One, increase of the speed, that we say we have a limitation, max speed. The second, using of baffles, baffle or promoters. Promoters, when we use feed spacer, in the module I speak, between membranes we use feed spacer for passing of the feed. The configuration of this feed spacer is very important and close to the turbulence. We can have a mesh-like feed spacer, okay? This is the structure of feed spacer, as you see in the module presentation. This is this structure that between two membranes, we can produce this feed spacer such as this one. With change of this angle, the turbulence can be changed, okay? Therefore, the design of the module can be very important in membrane fouling. And if our membrane is fouled, we have a hydraulic cleaning, that means washing only with water. Mechanical cleaning, that we use ultrasonic. We use bubbles for cleaning. Chemical cleanings are chemical, we use chemicals such as acid-base surfactant. Electrical cleaning, in some cases, we have an electrical field outside of the pressure vessel, and induction of the electrical field to the cations and anions reduce the fouling. This is electrical fouling. As a membrane modification, as a second, there are many methods for improving the anti-fouling properties of the membrane. One method, improve hydrophilicity for MF, UF, NF, RO membranes, okay? In this case, one famous method is grafting of some hydrophilic monomers, macromolecules, or polymers on the membrane surface and producing brush membranes. Brush membranes. As you see, it is similar to meswak. Huh? You say meswak, toothbrush. This is similar to the toothbrush, and this chain, this brush, do not permit molecules want to attach the main polymer. But this brush do not permit, and this is also have a movement, and the movement of the feet velocity can separate the attached molecules from here and reduce the attachment of the foulants to the membrane surface. or we can coating. We know coating is the physical attachment, but grafting is mechanical attachment. If we can prepare this layer with a graft, is better than the coat because the stability is higher. Or we can blend the different hydrophilic nanoparticles and polymers or macromolecules to modify the hydrophilicity of the membrane during the membrane fabrication. In this slide, show some pretreatment method for reducing inorganic fouling. As we say, we can use the anti-escalant. We can remove the calcium, magnesium as a softening agent. We can use acidification for decrease the plasticity, or we can use the thermal water softening, such as distillation, for reducing of the software. For organic fouling reduction, we must remove the organic agent. That most used process is coagulation with addition of aluminum and iron salts to water and use of calcium hydroxide, some precipitation produced and adsorb the organic matter and remove from the water. We can produce the antibacterial membranes with addition of the antibacterial agent. For example, silver-based nanomaterials. We know the silver have antibacterial properties. Zinc oxide is the famous. Graphene oxide, boron nitride, or we have antibacterial polymers also. We can mix with antibacterial polymers. And when we have an antibacterial agent, we see this is the live bacteria, and this is the destroyed bacteria. When we have an antibacterial agent, the bacteria can be dead, and the cell membrane of bacteria can be destroyed. Or in this example, when we have a knit PVC, Bayer PVC, that have not antibacterial agent, we see the growth of the microorganisms, and with addition of low amount of zinc oxide to the PVC, the surface is very clean. And this is show that we can produce the antibacterial membranes. For increasing of the hydrophilicity, we can also modify the main polymer. When we have a polysulfone, with addition of the functional groups, such as sulfonic, such as carboxylic, such as hydroxyl groups, we can increase the membrane permeability and antifouling properties. For this production of these groups, there are different methods. One is the plasma treatment. Can oxygen plasma can produce the radicals and cause to the hydrophilic surface on the membrane surface. Or with production of copolymers produced from two different polymers, with combination of the hydrophilic polymer with hydrophobic one, we can increase the hydrophilicity of the membrane. And when in this research, when 10% ethylene glycol is inserted to the polysulfone structure, we see that the permeate is very, very increased. We can graft the many functional groups to the membrane surface. We have a UV-induced or plasma-induced grafting. For grafting, we must first active sites. For producing active sites, we can use UV irradiation, plasma irradiation, or gamma and other high energies. Blending of additives, hydrophilic additives, can locate on the surface of membrane and inside of the membranes and cause to the decreasing of the fouling attachment. For cleaning, we say we have a physical cleaning that use water as a hydraulic cleaning, or mechanical cleaning with use of ultrasonic and bubbling and others. Usually, the physical cleaning is a few minutes in the industry. For cleaning, washing with acid base, we usually 1 hour use. For mechanical and physical cleaning, we use 5 minutes because we want the water can wash the membrane surface. But in the cleaning, we need time for reaction between cleaning agent and fouling. For example, we want to remove the scaling. When we use acid together with EDTA, acid and EDTA should be go and react with calcium carbonate, calcium sulfate for dissolving it. And dissolving need time. Therefore, we usually use 1 hour. We do not use more than 1 hour because more contact causes to the damage of membrane. And rapidly after cleaning, we use the water for removing of the cleaning agent. In the washing of membranes, we have 2 types of washing. One is forward washing, second is reverse washing, or back washing. Forward, reverse, back. 3 types, okay? Back wash, that means we insert the permeate from bottom to surface. We usually filter from the surface to the bottom. Backwash, that means we return some of permeate from bottom to surface, and this movement from the permeate side to feed side cause to entrance the molecules and remove this layer, okay? This called is backwash. But we have a forward and reverse washing or flushing. In this case, we only, instead of feed, we use the water from the surface of membrane, okay? In the forward flushing, our direction is similar to the feed. When we have this model, feed come here, and here is concentrate. Okay. In the forward wash, we close the feed value and open the wash value, wash valve. With opening of the wash valve, forward, parallel to the feed is clean. But in the reverse, we have this side. We have used the washing from the concentrate side to feed side. In back, what happened? in the backwash, we used washing from the backside, okay? Forward, reverse, and back flush. This is the back flush. For washing and cleaning, we measure the pressure drop or flux drop. Our flux, for example, is 100. When reached to the 50, we say that our membrane should be clean. And this time maybe 1 day for UF or 6 months for RO. After reaching to this criteria, this critical point, we must wash the membrane. But with washing or cleaning, we usually do not reach to the first flux. And the flux is lower than the initial flux. And after another period, we again wash, and we repeat this process. And after 5-6 times for RO membranes, or 1,000 times for UF membranes, the recovery of the flux is very low, and we must change the membranes. This diagram is for flux, and this diagram is based on the pressure. In industry, we want to produce a product, and the product capacity should be constant, okay? We want every day have 100 liters of product. But when flux is reduced, our product will be low. For this purpose, with the decreasing of the flux for keeping of the product amount in 100 liters, increase the pressure. Our applied pressure should be 2 atmospheres, but because our membrane is full and the product is lower, therefore increase the pH to reach 100. Tomorrow, more increase the pressure. And after 6 months, the pressure reached from 2 atmospheres to 6 atmospheres for keeping the amount of products. Therefore, in industry, most use this method for finding the backflushing time. Therefore, with keeping of the pressure, with increasing of the pressure, we have a constant productivity. I go from. As a mechanical washing, we can have a bubble flow from the water, and this bubble can increase the membrane cleaning, that's named as air flushing. We can use ultrasound. Ultrasonic can produce very small bubbles and can cause the attachment of the pollutants from the membrane surface. And finally, if our fouling is very bad, we have to use the cleaning agent. We have 2 types of the cleaning: clean in place and clean out of place. Most of cleaning is cleaning in place. That means we do not exit the module from pressure vessel. Only instead of feed, we insert the cleaning agent. Or in the backwash, we insert from the permeate side. Therefore, in clean in place, that's mainly CIP, we use the cleaning agent in that place, but in very bad fouling, that in many cases we use the cleaning in place, but the flux is not come back. Therefore, in these special conditions, get out the models and go to the lab, and in lab with different chemicals, test for recover the models. I go on this table. So for summary of the cleaning agent based of the fouling material. Okay, this table is important. When we have a biological fouling and natural organic matter or synthetic polymers, polyelectrolyte, the best chemical agent is sodium hypochlorite. Sodium hypochlorite can produce from reaction of NaOH with chloride. This is a strong oxidizing agent and can oxidize the organic matters. All of these three, biological, NOM, and synthetic polymers, are organic matter. And organic matter can be good oxide with hypochlorite. Or we can use another oxidant. Another oxidant is hydrogen peroxide. Hydrogen peroxide is expensive, but hypochlorite is cheaper one. And for natural organic matter, we can use NaOH. NaOH can react with organic matters and produce soap. Washing soap produced from fatty acid and NaOH. Okay? We use the soaps for our washing, usually prepared from fatty acid plus NaOH. We can use the ship fatty and NaOH, and when we boiling the ship fat with NaOH, we can produce the soap. Sabun, you say sabun? In Iran, we also say sabun. This is the reaction of the NaOH with NaOM. NaOM, most of this similar. The structure have this fatty acid. Therefore, when we add NaOH, react with NaOM and produce sabun, and sabun can be easily washed from the membrane surface. For inorganic deposit, inorganic scaling, we use acid. Acid is better. Citric acid, sulfuric acid, or chloric acid. Acids can dissolve the inorganic materials and remove it. Or we can use the complexing agent for removal of the metals or inorganic. For removal of the manganese and iron that is high in the well water, the sodium bisulfite as a reductant agent is good. Hydrogen peroxide and hypochlorite is oxidant. SPS is reductant. With reducing of the iron, we can be removed from the membrane surface. This table is good for selecting of a good cleaning agent. The parameters that affect the cleaning, one, the chemistry of the cleaning agent that we discuss in this table, but the cleaning time is important. Sometimes 30 minutes, 1 hour, 2 hours, based on the chemicals. Temperature is important. We can increase the temperature of the cleaning agent and increase the reaction velocity. Our concentration of the cleaning agent is important. In some cases, we use the acid with pH 1, in sometimes pH 2. And with change of the pH, that means the concentration change. Our concentration of EDTA is important. No need for it. Thank you. If I have any question, what's about it? If any question about the cleaning, fouling.
So what is sponge cleaning?
What it is?
Sponge in mechanical cleaning.
Sponge ball? Ball, yes. It is most used for the some hollow fiber membranes and plate and frame membranes. The use of the sponge ball, okay? Sponge ball.
Sponge.
Yes. We cannot use sponge ball in the module of the spiral wound because cannot entrance to the membrane, but in the plate and frame, we can use them. In some hollow fiber, we can use.
What is the mechanism, how it works?
I don't understand your question.
What is the mechanism, how it works?
Mechanism of sponge ball.
Cleaning.
Sponge ball cleaning. Mechanical.
Mechanical,
yes. Such as the washing of the dishes. We have a sponge that come and mechanical removal of them. Question?
So any other question from the participants? Yeah? So please feel free to ask. Because, yes.
One general question, sir. Sir, what should be an ideal state of a membrane?
Ideal?
State, I mean tensile state.
Tensile, ideal tensile. Ideal tensile based on the membrane type is different, but you want amount for
for liquid separation.
Liquid.
So I mean.
In UF.
Yes.
In commercial membranes, most of commercial membranes produce on non-woven fabric. And non-woven fabric very, very stable, such as this cloth, no tear. But when we have a membrane on glass, this stability can differ from one polymer to another polymer. And for example, for cellulose acetate, we have a very strong membrane. But for biopolymers, we have a very lower. But the best one, we have a test for measuring of the stability of strength of membrane as a tensile. We have a 2 in 5 centimeter samples and give to the lab for testing of them. Have a 2 constant of them and began to stretching of them. Usually the best one in the tearing point have a 50% in elongation. Okay. We have elongation. 50% is good. because we do not more flexible or more rigid. And the second parameter report, it is the strength of the membrane, and usually 70 megapascal is good. When you check the membrane for polyethyl sulfone, polysulfone, PVDF, the reported good data is 70 megapascal.
Commercial membrane?
Commercial, no, for lab. Because commercial paper is on non-woven fabric, and the strength is more 300 megapascal.
So
In the commercial membrane, usually do not report the strength because the non-woven fabric produce the strength. But in some membranes, such as Nafion, such as gas separation, maybe we have not support. In this case, usually because the membranes are not porous, such as Nafion, Nafion is very strength, and you cannot tear them. Gas separation also is very, in this case, more than 100 megapascal is strength.
Thank you.
So maybe I would like to add one thing here, that whenever I see more porosity of the membrane, we have less mechanical strength.
Yes.
Whenever we go for lesser and lesser porosity, then the membrane becomes strong. If we have highly porous membrane, then the mechanical strength becomes less.
Yes.
But whenever we add the support, then that becomes the dominating part of the strength.
Yes.
Here. So
Therefore,
yes.
the non-woven is very important,
Yes.
and we cannot tear the RO membranes because very, very strength. But the polysulfone can be easily destroyed. But when caught in the fabric produces the stability and strength.
Thank you. Thank you all for joining in this tutorial session. So this was the last tutorial session. So and I would like to thank all of you for participating actively in the discussion and listening very carefully and attending all the lectures and taking notes. I have seen reasonably good enthusiasm among the students, but I hope that as our sessions progress in later courses, we will see even more participations in terms of the discussion and question and answer. So thank you all for joining for the tutorial and the lectures today. That was the last tutorial session for this course. And so I request all of you to please join us for lunch in 312. At 2 p.m. I'm going to publish the questions for the quiz, and so I would request all of you to please submit by 3 p.m. You can use either your own laptop or your own smartphone. That way it would be very good. Okay. Thank you so much. And the certificate distribution, we are going to start around 3:30 p.m. Okay. Thank you so much.
Thank you. I also for
Actually, sir's input and sir's experience was huge in this sector. And when I was scheduling this course, I was thinking that I'm allotting so much time for him. He will be tired and he will be angry with me. Why you have given so much time for me to talk? Now sir was telling that time is short. His knowledge is so much. He has so much to give us. And that's why, so I'm so proud to have him here in today's, in this session with his knowledge, and that clearly shows the accuracy he has achieved in his life. So thank you for sharing your immense knowledge with all of us. And so I request all of you to please join us for lunch. Thank you.
Thank you. I suggest to give a photograph.
Yes, we have photograph in the valedictory session.
Okay.
So I hope you will